I want to say a big welcome to everyone on this call. We are about to do something incredible that will change the circumference of your entire life when it comes to this course. Already, right now, we have learned about deterministic models, linear programming, integer programming. All of these network models, all of these are deterministic because you are looking for something, you are determining something, x1, x2, inside. But now we are going to something we call probabilistic. You are not determining it, but you are making probability measures. And therefore, we are going to look at probability. Someone might be asking, why are we looking at probability? What is probability? Now, first, why are you doing something is more important than what is that. It's more important than how are you doing. The how is not important as the why do you have to study probability? And this is why. Because sometimes in life, we make hypotheses, we make gestures, we make conjectures. We take samples and we make wrong conclusions based on the samples. I think that looking at the people I saw there, most of the people are hungry. You are making a generalization based on a microcosm of information you have. And in life, we want to know the chances of something happening. For example, what is the chance that the next pandemic will hit next year? What is the chance? What is the probability? The word chance is the same as probability. What is the probability that this pregnancy is going to bring about a boy or a girl? What is the probability? We like to know that because life is uncertain. So you wish you are able to know the certainty. You see, for the linear programming and the other ones, we are certain that we're going to produce. It's just a number of how many. But probabilistic models are not like that. So these are the reasons why we look at probability. It is the chance of something happening, of an event occurring. And what is interesting is that the probability of an event occurring is written as probability of an event occurring. The probability of an event occurring plus the probability of the event not occurring is equal to 1. The probability of the event occurring and the probability of the event not occurring, write everything down. You see, write everything down. There is an information transmitted between your fingers through your skull into your brain that creates a mind. And so even sometimes when you don't understand, once you are writing it, your brain is receiving dopamine as a result. Okay, now let's move on. If you draw a card from a deck of cards, that is an event. And what I just said is here, the probability of an event occurring is added to the probability of the event not occurring, and that will give you 1. So it means that total probability of an event occurring is between 0 and 1. That's the total probability. Let's take a quick example. This is general. We know this from secondary school. Okay, let's consider an event E, okay, of rolling a dice. So we roll the dice. How many sides does a dice have? Type it there. How many sides does a dice have? Okay, I got 6 sides. 6 sides. Good. 6 sides. 6 sides. Okay, good. Now, when you roll the dice, what is the what is the probability that the number 6 will happen? Who can tell me? What is the probability that number 6 is going to happen? The probability that number 6 is going to happen is 1 out of the sample size. The sample size is 6 sides. So the 6 is one of them. What is the probability that the number 2 will happen? What is the probability that the number 2 will happen? What is the probability that the number 2 will happen? The chances of 2 happening is what? It's still 1 over 6. It's still 1 over 6 because 2, it happens only once between the 1, 2, 3, 4, 5, 6. These are the basics of probability. Got it? Michael, you have a question? Now let's look at what is on the screen here. You have an event A, an event B. Two events you have. Okay. And we can look at the probability of event A happening and the probability of event 2 happening. Now, the probability of event A and event B happening is called mutually exclusive event. Now, these two events are mutually exclusive because they are not together. They are disjoint. They cannot happen at the same time. For example, right now, you cannot be listening to me whilst at the same time you are having a dinner in maybe England. The two are mutually exclusive. Can't happen. Now, if you have events that are mutually exclusive, then you can have events that are not mutually exclusive. If they are not mutually exclusive, it means that they can happen at the same time. Because they can happen at the same time, after you have created a probability of having a male and the probability of having a female, you can take out the probability of having a male or female. That's called joint events. So a joint probability is that in which two or more events are not happening at the same time. Let's take, for example, this. This is a male, this is a female, and this is a male and female in the middle. And these are the basics of probability. Let's take a typical example, okay? And please move along with me. Move along with me. The dean of the business school has analyzed the scores. I've not started probability. I'm just giving you the basic. Okay. And these are the records of 3,000 students. And we've seen this situation over the past 4 years that out of these 3,000 students, they didn't want to know the number of students who had A in management science. He wants to know the number of students who had B, who had C, and all of that. Now, so the staff developed the following table. Let's look at the table that shows those who had what. Now, when you look at this very carefully, okay, you will notice something very interesting. If you look at the number, those students out of the 3,000 who had A are 300. And those students out of the 3,000 who had F are 150. Can I ask you a question? My first question. What is the probability that if I pick a student, I close my eyes, and I randomly pick a student from out of the 3,000 students, what is the probability that that student had a C? Who can tell me? What is the probability that that particular student had a C? Roberta, you have an answer? What is the probability? Yeah.
That would be 1,500 divided by the total.
And what is that?
That would be 0.5.
What is the total?
The total is 3,000.
Okay, good. So that's good. So what it's going to be is the probability that a student had a C is going to be 1,005 divided by the sample size. That is 50%. What is the probability that a student selected at random had an F? It will be 150, okay, divided by 1,000. That's what it will be. 150 divided by 1,000. 150 divided by 3,000. 150 by 3,000. And then you can find that percentage. But here's another one. Focus. Focus. If you pick a student, okay, now this is some of the answers that you just gave. Find the probability of a student getting A or B, but not both. What do you think that will be? You don't need to give me the exact answer. You just need to tell me something by something over something by something. Okay. Find the probability of a student getting A or B, but not both. A or B, but not both. What will it be? You can raise your hand and tell me, or you can type how you think it's supposed to go. What will it be? Nathania, what will it be?
Okay. Say please, it will be, the answer will be 0.3.
How did you get that?
That will be
Sorry.
making 0.3.
Sorry, start again. You lost you. That would be.
Yeah. So I'm saying that that will probability of A plus the probability of B, which will be 0.1 plus 0.2, making 0.3.
Probability of A plus the probability of B, 0.1 plus 0.2. And by the way, he's taking this probability of A. Okay. It's also done that of the probability of B. This is how you work it. This is how you work it. It's not clear. You gotta be clear. These are the basics. These are the basics. So now let's assume that you are not getting it. What do you do? Well, you write what you can write, and then later on, you go and check the rest. You go and check the rest, you dig into it, and then you familiarize yourself fully with that. Now let's go to the real things in life. Now let's learn how to model or describe the process of taking a sample from a population. So I can look at a population of students, and then I'll take a sample from that population. Now, because there are many different types of data, and you can have data on height, data on weight, data on, salaries and all of that, okay? There are many different ways we might collect a data from a sample, a data sample from a population. And so we need so many probability models to do that, because life doesn't always move in a particular direction. For example, there are certain things that move at the speed of light. Some things move in waves. Some things are moving in a different direction. For example, if you take gender, okay, is it gender or sex? I always get confused with that, okay? Gender, okay, no, sex. If you take sex, it can be male or female, right? It can be male or female. So the only possibility is going to be what? 2. And so the 2 outcomes make it not normal. It's not like the others. It is a discrete variable. It is finite. It's not continuous. And so the way it looks like, anytime you're talking about the sex of a child, there are only 2 possibilities. And because there are 2 possibilities, it means that the way you model that thing is different from when you're looking at the age of a child. When you're looking at the sex of the child, it will be modeled, it will be described differently from the age of the child, because the age of the child can be different things. So the manner in which we describe the process of taking a sample, or the manner in which we describe a situation, a phenomenon happening, we can use different models to look at it. And there are several distributions. The distributions tells you the way the thing looks like in reality. And one of the distributions is known as the binomial distribution. Binomial distribution. Another distribution in which certain things are is Poisson distribution. Poisson distribution. Another distribution is known as normal distribution. Another distribution is known as Weibull distribution. Another distribution is known as exponential distribution. Another distribution is known as truncated normal, gamma, okay? And then several other distributions. You can even have half normal. Life and things in life are not the same. Even look at your face and look at your children's face. They are not the same. And so things are separate, different. And because they are different, the way you describe them must be different. Let's take the first one, which is the binomial distribution. Okay, sometimes it's called the Bernoulli triad. The characteristics or the properties of the binomial distribution, I want you to write each one down, even if you see it on your screen. One, the two outcomes of each trial is what you have. So the binomial distribution tells you that there is always what? Two outcomes. That's the first one. Note it down. Two outcomes. The word bi is two. So think about examples, because I'll come to that to tell me some examples. Number two, the probability of the outcome is constant. It's constant. So let's take a typical example. If I throw a dice, I'm giving you an easy one. Sorry, if I throw a coin, what are the outcomes? If I throw a coin, the one they use when they're about to play football, into the air, and boom, it touches the hand, and then the referee turns it. What are the outcomes? Right, just type it there. What are the outcomes? Head or tail, exactly, head or tail. The outcomes are two, head or tail. Now, because the outcomes are two, watch this. The probability that the outcome is head is how many percent? The probability that it will be a head is how many percent? What are the chances that if I throw it into the air, it will be a head? It's 50%. Exactly. Exactly, 50%. Okay, now that outcome, that probability of the outcome must remain there. It must remain the same every time. So if you tell me that the probability of the outcome is 50%, it gotta be 50% every time. That's one feature of a binomial distribution or a Bernoulli triad. Take note of that. So one, there are two outcomes. Two, the probability of the outcome is constant. Three, the outcomes don't depend on each other. If I throw the first one and it's a head, and I throw the next one and it's a head, and I throw the third one and it's a head, and I throw the fourth one and it's a head, so I've got head how many times? 4 times. Then I throw the next one is a tail. I throw the next one is a tail. You might be tempted to think that, oh, then the next two will also be a tail because the first 4 are head. So the next 4 should be tail. No. There is no independency in that regard. Number 4, the trials are distinct and integer. We are talking about whole numbers. So if it is a head, it's a 0. If it is a tail, it's a 1. If it is a head, it's a 0. If it's a tail, it's a 1. These are whole numbers. They are no decimals. They are no decimals. They are no decimals. The trials are, what do I mean by the trials? The number of times I'm performing the event. Next one. Number 5. Okay, so there's basically 4. So take note of these things. Now, at this stage, if you have a question, let me. Bernoulli triad. Now let's go to the next thing. When you look at a random variable can have a binomial distribution. I just gave you an example. A random variable is the sex of a child. Okay, this can have a binomial distribution. And we've already seen that this can happen when the probability of the outcome are just 2. Now watch it. The probability of the experiment has got 2 outcomes. The probability of success is called P. The probability of success is P. The probability of not a success or failure is 1 minus P. So what is the probability of success and failure? Write it there. What is the probability of success and failure? What is the probability of P plus 1 minus P? I mean, it's obvious, eh? What is the probability of success and failure? This is success, and this is failure. What is the probability of success and failure? Type somewhere, okay? It's 1. And you can see it's P minus P 0, then you're left to 1. Keep these as we move gradually towards the beauty of today's one. Now, If you have a coin and the coin is tossed 1 time, 2 times, 3 times, 4 times, the outcomes are still going to be 2 possibilities, head or tail. That's why it's a binomial. Who can give me some things that are binomially distributed apart from tossing of a coin? What else is binomially distributed? Give me one example. Give me one example. Type one example. Type one example. Give me one example. Be proud. Tell yourself, today I am going to be so participatory. I am going to soak myself into the learning. Nothing will stop me. I am the head. I'm not the tail. I'm the alpha. I'm the omega. I define my path. I will win. Because if I don't, I'll perish. Give me an example. We've already spoken about sex, so you can't tell me sex again. Come on. Passing an exam or failing an exam, of course. True or false? I like the true or false. Okay, Godwin, that's good. Life and death. Okay, good. I love that. Okay. Accepting a proposal or rejecting a proposal. I love that, Anna. Okay. Male, because we already looked at that. See, when you go to gender, it's a little bit difficult there. Let's go to, yes, I like Linda, I like yes or no, win or lose. Okay. Everybody's writing win or lose. Okay. Day or night. No, I don't think so. Because you can't really check exactly what I take or reject. I love it. Love it. You guys are giving some very good examples. Okay. Now, these are some of the examples. Defective or not defective light bulb. Get or not get a contract. Okay. Yes or no, and things like that. Okay, now, you have seen example, accepting a job offer or rejecting the job offer. Let me tell you something. Anytime you are trying to understand any distribution, you got to know certain things about a distribution. And please note, the first thing you got to know about a distribution is the mean. The second thing you got to know about a distribution is the variance or the standard deviation. The mean measures the center. The variance or the standard deviation measures deviation from the center. All these two are the main thing that will tell you about the distribution of a random variable. Take note of that. So we'll look at binomial, Poisson, and normal distribution. These two will always come up. Keep it. Keep it with you until you decay. Okay, now, on the basis of this, let's go to the formula for a random variable the probability formula for a binomial distribution. So look at the distribution first. What we mean by the distribution. Okay. The distribution is made up of n independent Bernoulli trials. So n here is a sample size. Take note of that. Write it down somewhere. Okay. And out of that sample size, we want to get something from the sample. Okay. So for example, the sample can be the ages. Sorry, the sample can be the number of times you throw a coin. You threw the coin 17 times. You threw it up 1, you threw it up 2, you threw it up 3, 17 times. So in this case, the sample size n is 17. Now, you want to check the probability that out of that 17 times you throw it, okay, 6 of them will be head. So you fished out the 6 of them will be head. 6 will be head. And that is what we call the success. So the 6 here is your X. The X is the number of success. Please note, the number of success doesn't mean it's a good thing. The success is not in the morality sense. Okay, success is what you're looking for. So let's say that you are looking at the road from Accra to Kumasi, and your success here could be how many accidents happen. That could be your success. The success is what you are expecting, not that the good thing you're expecting. And that is what we have here, the X. That is the number of success. So it means that the total sample size is part of the successes, as you can see here. Now, with that in mind, this is a binomial formula. Write it down, and I'll show you something. Write it down. Write it down, please. Write it down in a pen and paper, please. Write it down in a pen and paper. Write it down in a pen and paper. Write it down. Write it down, please. In a pen and a paper. With a pen and a paper. With a pen and a paper. Write it down. Write it down, write it down, write it down, write it down. You are not writing, write it down. Everybody's writing except you. Write it down. You see, write it down. You see, write it down. As you're writing it down, you're going to use it very soon. So writing it down will transmit information between your fingers to your brain. That's why I wanted to write it. Good. Who can tell me what does the N stand for? What does the N stand for? You can raise your hand or type it there. What does the N stand for? What does the N stand for? What does the X stand for? Okay, I'm getting answers like sample size, sample size, sample size. N doesn't stand for independence. Okay, that's not correct. I love those of you talking about sample size. Okay. N is the sample size. N is the sample size. You might call the number of trials. Okay. Don't use words you don't understand. Don't use words you don't understand. Okay. What does the X stand for? What does the X stand for? What does the X stand for? X. X is the number of sexes. Good. X is the number of sexes. Very good. What does this exclamation mark stand for? What does this exclamation mark stand for? You can tell it. What does the exclamation mark stand for? Okay. Somebody says factory. It's not factory, it's factorial. Okay. Factorial. That's a good answer. Ernest. Factorial. Factorial. What does that mean? Okay. What does that mean? You got to understand what a factorial is. Factorial is a multiplication of a number in a descending order until you reach the minimum number. What do I mean? What is 3 factorial? 3 factorial is equal to what? Don't tell me the answer. Tell me the process. 3 factorial. Watch this. The page, the great answers people are giving. It's 3 times 2 times 1. What is 4 factorial? 4 factorial is 4 times 3 times 2 times 1. Good. Now, what is 1 factorial? What is 1 factorial? I want the answer. What is 1 factorial? Priscilla. 1. Good. Good. 1 factorial is what? What is 0 factorial? What is 0 factorial? Can be. Okay? Can be. What is 0 factorial? What is 0 factorial? Somebody says 0 factorial is 0. No. 0 factorial is 1. So keep that in mind. Keep it in mind. Take a calculator. Take a calculator. Take it. Okay. And again, go look for 0. And then after looking for 0, you check it yourself. You see, life does not reward you according to your wish. Life rewards you according to the quality of your wish. That's life. The quality of your wish. That is life. So sometimes you might not know something, but somebody tells you, you got it. Go and find out why 0 factorial is 1. It's a beautiful thing if you find out. Okay? And the reason is because there is no positive value less than 0. So if you have a data set, the data set cannot be arranged, which will count as the possible combination of how the data can be arranged. It cannot. And that is why 0 factorial is 1. Take note. Why is 1 factorial 1? Yeah, I mean, that one is obvious. Okay. But the one that normally tricks people is the 0. Okay, so now we got 0 factorial, we got 1 factorial. Now, keep that in mind. So these things, these are the definitions of them. By the way, the P is the probability of a success. The 1 minus the P is the probability of not a success, which means it's a probability of failure. Now that you've written this thing down, let's move on to the next thing. What are the mean and the variance of the binomial distribution? I told you. The mean of the binomial distribution is given by this number here, the one at the bottom here. Watch it. This is the mean. This, ladies and gentlemen, is the mean. What does it mean? What does the mean mean? Watch this. This one means the probability of the random variable. So you should, first of all, you should have the value called x. Okay. Then you should have a column called probability of the x. And what you now do is that, let's say you have 2, 4, 8. And the probability of this is 0.1, okay, 0.4, and then 0.5. You see, I wrote the probability in such a way that if I add them, I'll get to 1. Now, if I want to find the expected value or the mean, remember, another word for the mean is expected value. If I want to find the expected value, I just take this number, which is a 2, and multiply the 2 by the probability, which is 0.1. Okay, so I create a column called x times x multiplied by the probability of x. Okay, that's a column here. So you take this one, multiply by that, you put it here. Take the next one, multiply by that, you put it there. The next one, multiply by that, you put it there. And then when you finish, you add all of them together, and that will be the mean of this particular information of x. So that's the mean. Now, how do you get a standard deviation? Well, check it here. This is the formula. The standard deviation is just take the mean. Okay, if you look at here, this is the mean. You take the mean, and then for each random variable, you subtract the mean from the random observation. So x minus the mean. Let's say the mean is, say, 2. To be x minus 2, where x is, say, 2. So 2 minus 2. Okay, and then you square it. You do the next one, then you square it. You do the next one. Each value minus the mean, each value minus the mean, each value minus the mean, each value minus the mean. Then you square each, square each, square each. Then you sum the square. Oh, no, before you sum it, okay, before you sum the square, you multiply the answer by the probability as well, okay, which in this case it will be this color. And then whatever you get, you sum it, and that becomes the variance. If you want to know the standard deviation, just take the variance. So the standard deviation is just the square root of the variance. That's it. Okay, we'll be looking at a couple of examples. That's what I'm telling you. And that is how you get this. So I told you that every random variable, you have the mean and the standard deviation. Finish. Good. Let's go to the next distribution. I'm giving you the theory before we start looking at examples. The next distribution is called a Poisson distribution. And guys, watch this. The only thing I want you to understand with this Poisson distribution is how different it is from the binomial. That's all I want you to know. What is the difference? I want you to know. Watch it. Watch it. Pay attention. Pay attention. You are not paying attention. I say pay attention, please. Focus, focus. Don't let that thing disturb you. Focus. Now, Poisson distribution looks at the successes, but the successes are looked at over a time period, over an interval. Remember, the probability looks at the success, but the Poisson looks at the success over an interval. So we are looking at the number of times something happens over time. The number of times, not the number something happens. Not the number of times something happens, not the number of trials, but the number of trials over a certain period. So there is a time element. So for example, how many goals were scored in a football match? That's a point. How many goals? You know that a football match is time bound, 90 minutes. And so when you say how many goals up, this, because it's time bound, it's not happening the whole day. This event is distributed Poissonally. It is a Poisson distribution because it is time bound. And your focus is on the interval. The interval can be the time associated with it, the space, or the length. For example, the number of arrivals in a shop within an hour. Because it's happening within an hour, it is time bound, and therefore it is a Poisson distribution. The goal scored in a football match is a Poisson distribution. The arrivals at a bank cash machine, they all arrive at a particular time period. Okay. Now, suppose you are playing a certain, or you are dancing, the number of times, or the number of dances in a 10 square feet meters. The space will define it. The space will define it. You are limited by the space in which you're operating. So for example, how many words are you writing per page of an exercise book? How many words? You got to write some of these examples I'm saying now. How many words in a page. That the fact that it's in a page means you cannot write beyond a page. The page is limiting you. So it's not the words, but the words are within the parameter of the page. And therefore, you got to find the mean because the page is limited. Okay? And so that defines the mean. If you take the number of goals scored in a football match is limited within 90 minutes. And so on average, you are limited by that 90 minutes. Poisson looks at that. Now, the best way you can understand Poisson is when I compare it with that of binomial. Okay, so let's take a couple of examples. So first example, binomial has a fixed number of trials. Poisson has infinite number of trials. So you can throw the coin, you can throw it many, many times, but at the end of the day, you got to tell me, within how many times that you threw your coin. Poisson gives you unlimited number. In binomial, let's move on. I think I switched to you a bit, but let's move on. I'm sure you can get me now. If you can get me and see my screen, please type Y. Type the letter Y. Let me be sure that we are on the same track. Fantastic. Okay, that's fine. So Poisson gives you unlimited number of trials. Another thing about the binomial is, I will repeat this, don't worry. The probability of success is constant. I'm sure you remember, we said it before, that the probability of success is constant. Okay. What about the Poisson? Let me go back. What about the Poisson? Poisson is not the probability of success, it's the mean of the distribution. The focus of the Poisson is on the mean. It's on the mean. The mean is the same for everybody. The Poisson, each trial is independent. We said it before. In binomial, each trial is independent. But in Poisson, the number of trials in a given independent, it is a number of trials within the mean, within the interval, within the gap that has been given. That is what is fixed or is independent of the others. And then, of course, finally, the binomial can be used to test for independence. The Poisson can be used to also test for independence. Let's get the main thing, because I've given you a lot. Let's single out the main difference. Here's the main difference. Watch it. Poisson focuses on the mean. Write it down. The mean probability. Binomial focuses on the actual probability, not the mean probability, but the actual. So in Poisson, before you talk about the probability, there are several probabilities, but you are taking the mean and you are dealing with the mean. But then in binomial, there is one probability. Okay, so for example, in the toss of a coin, the probability is 50% for the head and it's 50% for the tail. That's it. One probability. But whenever we're talking about Poisson, it is the mean, the average probability. That's what we are dealing with. And no example will be more efficacious than preset. I know the more I give you examples, the more you get it. Okay. So I'm going to ask you some things. First thing, and this is the most important thing, okay, in probability between the binomial and Poisson, your ability to identify whether it's Poisson or it's binomial. So let's start with the first one. Your job is to tell me whether these things I'm having on the screen, which one is Poisson and which one is binomial. You raise your hand, you tell me. Let's start with the first one. The number of imperfections per square meter of glass panel used in making LCD TV. Is it binomial or Poisson? If you guess, minus 1 million. I don't like guesses. This is not a guess time. Okay. Let's go to Ernest Edu-Owusu.
Doc is Poisson.
Why?
Because per square meter, that's space.
Thank you. Next one. Be careful. Whatever answer that came into your head, be careful. Be careful. I know. The number of foot robot malfunctions per day in an assembly line. Poisson or binomial? Poisson or binomial? Okay, Akosia dance. Poisson or binomial?
Because Poisson.
Why?
Because per day is time bound.
Excellent. Last one. The number of telephone calls arriving at the help desk of a software company during a 10-minute period. Be careful. Poisson or binomial? Poisson or binomial? Lawa. Poisson or binomial?
Poisson. It's Poisson.
Very good. So guys, they were all Poisson. I just deliberately checked to see whether you choose a binomial. Okay. So with that in mind, let's move on to the next one. Okay. We need to write the formula for the Poisson, and this is what you have here. Write it down. Write it down. Write it down. We'll be using this very soon. This is the formula for the Poisson. I will explain everything. Okay. But remember that the most important thing about the Poisson is the mean. Remember we said that the mean of success is key. And the mean is always represented by the lambda. So within the Poisson, you don't have, you see, one thing about the previous one, the binomial, is that the binomial, you will have to know the probability of success and the probability of failure. Poisson, you don't have that. Okay. You are rather going to find the probability of success over time. Over time, that's what you're going to find over the mean period. Okay. But the mean is given to you. If it is not given to you, you got to find a way to get a mean. And there's always a way. Now, how do you find mean? Mean is generally given by x bar, if you can remember. And it is a sum of the x divided by n. Write it down. That is usually how we find mean. So it is a random variable, the sum of the random variable divided by the sample size, that gives you the mean. Okay. The next thing you have here is E. E is the base of the natural log, which is always 2.718. Note it. No one will give it to you because this is always on your calculator. Okay. 2.718, that is the natural log. That value is here. So the formula is saying that take the natural log, which is 2.718, to raise to the power negative lambda, where the lambda is the mean of success. Okay. Mean of success per time or per the interval. And then the x is what the question is always about. So given the mean, now I want you to tell me this, and that is the x. So the x is the number of success. Remember, the lambda is the average of the success within the interval, whereas the x is the number of the success within the interval. And that is what you are always supposed to, you are always supposed to find. I mean, that is always given to you, but that is what you are finding is probability. You are finding the probability of the number of success happening, okay, given the mean, and of course the natural log, the base of the natural log. So this formula is necessary whenever we come to the practicals. Put it down just as you put the binomial formula down. We'll be referring to them very soon. It's not clear. Good. Now let's move on to the next thing. You remember I told you that every time you have a random variable, normally distributed, you need to find something about the distribution. And I told you that always whenever you are finding something about the distribution, there are two things you need to find about the distribution. What are they? Tell me, you can tell me, what are they? Two things you got to know about the distribution. Philip.
So you need to know the mean and the standard deviation.
Good. Or instead of the standard deviation, you also have to know what? Instead of the standard, you can also know what?
The variance.
What is the difference between the two?
The mean is a measure of central tendency.
No. What's the difference between the variance and the standard deviation? Philip, are you there? Yeah, there. Okay. Michael.
The square root of the variance will give you the standard deviation.
Super. Let's move on. Okay. So now we have this is the mean. The expected value of X is a mean. And the interesting thing about the Poisson is that the mean is a lambda and the standard deviation or the variance is also the lambda. Take note. The mean is a lambda, the standard deviation is a lambda. They are all the same. Go and find out why. Not why, but go and find out why. It's the same. It's the same. So the previous one for the binomial, the mean was complex. The standard deviation, the variance was also complex. But this one, the Poisson, you can see that the mean is simple. The mean is a mean. The mean is the expected value of the random variable. The standard deviation is it. Okay. I'm going to give you a typical example. Your job is to tell me first whether this thing requires binomial or Poisson. That's the first thing you're going to do for each question. Tell me whether it's binomial or Poisson for each one. Get ready. Tell me whether it's binomial or Poisson. Get your calculator ready. Get your calculator ready. Get your calculator ready. Get your pen ready. Get your book ready. Let's grow. Let's roll. So first question, is this binomial or Poisson? Here's a question. The question is actually, what is the probability of one success in 5 observations if the probability of success is 0.1? Is this binomial or Poisson and why? Is this binomial or Poisson and why? I'm interested in the why. I'm not interested in the guess. So you can type your guessing in the chat here, but I want one of you to raise a hand to tell me why. Priscilla says Poisson. Barbara says Poisson. Let's go on. Let's go on. Let's go on. What is it? Say some. Is it binomial or Poisson? Say some. Say some. Say some of it. Be an active participant. Do not be a passive participant. This is the easiest one, by the way. Is it binomial or is Poisson? I know you can do it. I know you can think through. I know you have something incredible. So Anna, let's see whether you got something for us.
Sir, please, it's Poisson, because if it were binomial, the outcome would be 0.2. But since the outcome is 0.1, it means there were 10 successes. So not 5 successes. But the question stated that the probability of one success in 5 observations. But if it were 5 observations, it will be 0.2. That will make it binomial. But this is 10 observations.
Good. But not quite right. Not quite right. You can tell us and give us a better reason. I mean, you can guess. All of you are typing your answers. You can always guess. That I know. But I need a reason. I need a reason. Why is it Poisson? Why is it binomial? I need a reason. Yes, Philip.
Sir, I think it's a binomial distribution because we can see a fixed number of trials. That is the observations, the 5 observations, and we can also deduce from the question that there are only 2 possible outcomes. That is success or failure.
Perfect. That's what I need. The best answer today. Okay, there are only 2 outcomes. 2 outcomes. You must always be able to identify the 2 outcomes. One is the word success. This was the easiest given. And therefore, we should know that there is a failure there. That should tell you that this is binomial. Now, once you've identified that it's binomial, you must have your formula in mind. And in the formula, there is something called n you should find. Remember the binomial formula? There is something called x. Okay, let me drop the x for now. There is something called p. There is something called 1 minus p. And finally, there is something called x. So from this, who can tell me what is the sample size in the question? Because this is binomial. And the proof of that is the 2 outcomes. The first outcome is success, the second outcome is failure. What is n in the question? Type it out for me. This one, we don't need the hand raise. N is 5. Excellent, Ernest. So n is 5. It's right in there. So you write 5. What is P? P is the probability of success. What is that? P is the probability of success. 0.1. That was explicit, very clear, given to us. Okay, very, very clear here. So that is P. So you write it down. So what is the 1 minus P then? What is 1 minus P then? Move along, move along, move along. Okay, that's 0.9. Very good. So 1 minus P is 0.9. Very good. What is X? What is X? X is a number of success. What is X here? Because that is what a question is asking. What is X? X is 1. Very good, very good. And this was in there. It says 1 success. So X is 1. All the ingredients necessary for you to find your probability are here. Put them into the binomial formula now and give me answer. Put them into the binomial formula and give me the answer. Okay. So this is a binomial formula. I want you to do this by yourself because it is only when you do this by yourself that you can prove it to yourself. Do it by yourself, prove it to yourself. So find it. Remember n factorial. What is the value of it? Okay. And X, we know every value. So when you're working this thing with your calculator, you got to do it in 3 parts. Okay. The first part is to find this part. And that is 5 factorial. Okay. And then in the down here, you have 5 minus x. X is 1, so it will be 4. 5 minus 1 is 4. And so 4 factorial and then 5 factorial are multiplied. 4 factorial and 5 factorial are multiplied. The second part is the next one, which is a 0.1 raised to the power x, and x is 1. The next one is 0.9. So it's 0.9 raised to the power n, which is 5, x, which is 1, so raised to the power 4. So you've now gotten the 3 parts. Okay. Any number, raised to the power 1, you know that is the number itself. And then you can now find the calculations and your calculator and everything. Find the value. I see some of you are giving me some good answers there. What do you have? What value do you have like the others? Work it, Nathaniel.
$0.33.
Good. So when you substitute all of this, you get 0.32805, approximately 0.33. This is your answer that you get. What does this mean? It means that the probability of getting 1 success out of the 5 observations, the chances of you getting that is 33%. The probability is 33%. We're done. Next question. This time we are looking at 3 tosses of a coin. So look at the question. What is the probability of getting exactly 2 tails in 3 tosses of a coin? What are we looking at here? Is it binomial or Poisson? Is this binomial or Poisson? That's the most important thing, to be honest. Bi or Poisson? Ernest says binomial, Michael says binomial, Priscilla says binomial, Michael says binomial, Samuel says binomial. What is it? It is binomial because there are 2 outcomes. What are the outcomes? Type the outcomes there for me. What are the outcomes? Outcomes, outcomes, outcomes. Head or tail, exactly. Head or tail, because we're talking about toss of a coin. Okay, so the toss of a coin is binomial. Okay, so it's binomial. Why? Because the options are head or tail. Okay. Now, with that in mind, we are now ready to know the binomial formula. So that means we need to know our n, we need to know our p, our 1 minus p, and then our x. Now, what is our n from this? What is n? The sample size here. What is that? The question is clear. Everything is here on our screen. N is what? N is what? N is what? N is what? Okay. N is 3. Exactly. N is 3. Okay. What about P? What is P here? What is P? What is P here? What is P? Now remember, this is a toss of a coin, a toss of a coin. So already, once it's a head or tail, it's always automatically 50%. So P is 50%. So 1 minus P is also 50%. Okay. Because for head or tail, it's always 50-50. What is X? In the question, what is X? What is X? And the word exactly means what? What does exactly mean, first of all? Remember, that word is probability of getting exactly details. So what is X? First of all, what does exactly mean? I love that. I love the answer by NS because it's written a very top class answer. Okay. Exactly 2 means equal to 2. So X is 2. X is 2. Okay. So we are looking for the probability that X is equal to 2, equal to, then you put it all into the probability formula. That's what we're looking for. And when you slot everything in, if you understand up to here, it's cool because it means that you are on track. Okay. When you slot everything in and you find the value, so your n must be in the formula, your all those other things must be there as we always wanted. Okay. We always wanted that. So this is basically the formula. Slot it into the binomial formula. You calculate everything, and you are ready to substitute everything, 2 tails, and so boom, calculate, and then boom. You got your 37 or approximately 38%. So the chances of you getting exactly 2 out of the 3 is 38%, 37.5%. That's what you have. Let's go to another one. Another one. Next one. Samsung Ghana gives a 2-year warranty on the phones it makes. It gives 2-year warranty. You see, example is more efficacious than precedent. I'm giving you more examples so you can get a point. Okay. Samsung gives a 2-year warranty on the phones it makes. From past experience, it knows that 0.5% of the phones will be faulty. 0.5 of the phones will be faulty and fail, which is the same faulty. They will fail and fail, or they'll be faulty and fail within the warranty period. What is the probability that out of a consignment of 500 phones, none will be faulty, more than 3 will be faulty? Question. Is this binomial or Poisson? Be careful. Is this binomial or Poisson? Think about your reason more than just choosing the binomial or Poisson. Don't follow the crowd also to your end. Is it binomial or Poisson? I like it when one of you gives me reasons. Somebody says because of the period of 2 years. It has time frame. When you say it has time frame, you haven't spoken. Why is it Poisson? And what is the time frame? Why is it Poisson? What's the time frame? Failure is happening within a 2-year warranty period. That's it. Okay. So everything is happening within a time frame of 2 year warranty. That's why we know it's Poisson. Ladies and gentlemen, ladies and gentlemen, ladies and gentlemen, ladies and gentlemen, this is Poisson. It's Poisson because there is an interval given already of 2 years. See, imagine that this thing is Poisson and you go and write binomial. Everything you work is wrong. Everything is wrong. Your capacity to determine what is binomial or Poisson is the first most important thing. Okay, now that we know that it's Poisson, we need to know the Poisson formula. Do you remember the Poisson formula? It has two main elements, basically three. Two main elements. The first element is the mean. The second element is the x. Remember that that one doesn't have any probability, of anything because everything is happening within a time frame. So what do you think is the mean here? What is the mean? Now, mean is always expected value. And the mean is always calculated based on sometimes historical data. So if I give you something like 4, 5, 7, because I'm giving you 4, 5, 7, 4, 5, 7 are historical. And because they are historical, I can now calculate the mean because I have the values. Mean is computable from historical data. So from this story, what is the mean? What does it mean? Now, the mean is found by looking at the historical means past. So it says that from the past, the company is aware that 0.5% of the phones will be faulty within the warranty period. 0.5% of the phones. Okay, 0.5% of the phones. Put it down. 0.5 divided by 100 of the phones. Now, in this very example, how many are the phones we are dealing with? How many are the phones we are dealing with? In this particular example, how many phones? How many phones? Exactly, 500. So because you're dealing with 500, 0.5% of the phones will be 0.5, 0.5% of 500. Now what is 0.5% of 500? 0.5 over 100 times 500. So once you cancel these two, okay, you are left with 0.5 of 5, which is what? I know the answer, but sometimes I love it when you guys give me the answer. Exactly. 2.5. So the average, remember that the lambda is a mean. The average of faulty phones is 2.5. Please don't bother to say that, but how can you have 2.5 faulty phones? Remember, it's a representation of the average. So it shouldn't be taken too lightly or to make an issue out of it. Okay. So now we know that it's 2.5. Now we are left with our x. Our x comes from the first part. The first part says that none will be faulty. None here refers to what number? None will be faulty. What does that refer to? None will be faulty. That's what? 0. 0. So our x in the first situation is 0. So now you got to write your binomial. The probability that x is equal to 0 is going to be e raised to the power negative lambda, and then the entire binomial formula will follow as a result of that. So how do you do that? This is slot store into the formula. Okay. E is 2.178. I told you. E is the base of the natural log is 2.178. So you write 2.178 raised to the power the mean, negative of the mean. Negative of the mean is 2.5, so negative 2.5. Then the same lambda, look at the formula. 2.5 to the power x, x is 0. So 2.5 raised to the power 0 is 1. Any number raised to the power 0 is 1. The 1 is multiplying the 2.718, which happens to be raised to the power negative 2.5. All divided by 0 factorial, which is 1. And so your final answer will be 8.2%. What does this mean? What it means is that there is a probability of 8.2% of no failures. What does it mean again? What it means is that if you have 500 phones, the chances of you getting no phone being faulty, the chances of you getting all the 500 to be clean is not a good chance. It's 8.2%, which means that you are having a least chance. In other words, there is a likelihood that one of them or two of them are faulty, because the probability is showing that your chances are slim. That's it. Let's go to the previous one, the question again. The next one says, what is the chance that more than 3 are faulty? Watch it. More than 3. Now, the word more than 3 is a very powerful thing. More than 3, do you know what that means? More than 3 means that, remember, there are 500 phones. Okay. And we are talking about the fact that what is the probability that more than 3 are faulty? So we are looking at the probability of X being what to 3? What symbol should I bring it there? What symbol should I bring there? You gotta understand these. Okay, what symbol? Excellent. Priscilla and Esther. Ernest. Excellent. So the symbol is greater than. Okay. But do you know what that means? That means that out of the 500 phones, we are going to find the probability that more than 3, and more than 3 are 4, 5, 6, 7, 8, 9, 10, 13, 14, all the way up to 500. Who, by the time we finish, all of you will be dead. All of us will be gone. And so we got to find a different route to make sure. And this is the route. The route says that probability is between 0 and what? And 1. So the probability of finding more than 3, that should be equal to 1 minus the probability of not finding more than 3. I want to repeat that. The probability of finding more than 3, that should be equal to the probability of not finding more than 3. So with that in mind, let's go back here. I can say that this is also equal to 1 minus the probability of something. Who can tell me? 1 minus the probability of something. I need a hand raise for this, because this is where intelligence plays a role. Okay? This is where greater people, will crack the code. Let me go to Anna.
So, it's 1 minus the probability of 3 not getting 3, like of the event not happening.
So what would you write?
1 minus P.
1 minus P would not be correct. So let's get another person. Let's go to Michael. What is the probability? 1 minus what?
1 minus P X less than or equal to 3.
1 minus P X less than or equal to 3. Correct. Because we are looking at more than 3. So more than 3 is 4 and above. So opposite of that will be 3 and below. That's all. But do you know there's another way of writing this? It could also have been written as something. Who can crack that final part? This one could also have been written as something else. Who knows about that? Could have been written as something else. Then this one is a bit tough, but let me see whether somebody can crack that. You could also have written it as 1 minus something. What? I like people who are really, really, really with me. Okay. Let's see whether Michael, you can crack it.
Okay, Doc. So it is the PX less than or equal to 3 can be written as 1 minus the probability that you have X equals 0 plus 1 minus plus x equals
No, we'll come
1
back to the
plus-
details. We'll come back to the details. I know what you mean. But it could have also been written as what? Oh, you could write this thing as x is less than 4. Does that make sense? Because 4 is not packed. So we could still write it as 1 minus probability of x is less than 4. Okay, so now let's go to the details. So this will be equal to 1 minus the probability. Now let's come to you, Michael. You're giving us the details. So in order to find this, we need to know probability of x what?
X equals 0 plus
X is equal to 0 minus probability that
x equals 1.
x equals 1 minus probability that
X equals 2.
2 minus
Probability that x equals 3.
exactly. So guys, this is what you got to do. Okay. And as for the first one, you already know it. What's the first one? The first one is probability that s is equal to 0. We know it. We just calculated it previously. Okay. So we just take it. So this is going to be 1 minus the probability that s is equal to 0. We solve that. Okay. This was 8.2. Okay. Okay. It was 0.82. So it will be 0.82. Then minus, you go and calculate the probability that s is equal to 1. Okay. How do we get that? It's simple. You just go and take the formula and then you substitute that. Let me show you how it will all turn out. It will turn out very beautiful. This is it. You can see from here that the probability that x is equal to 1 is almost 21%. The probability that s is equal to 2 is almost 26%. The probability that s is 3 is almost 21%. And so we get 1 minus all of that. And that is what is at the bottom here. Oops. And that gives you 24.2%. Finish. So you just take the one and subtract all of these answers. So you can see that first was the 0, the probability that x is equal to 0. This was it. This answer was found previously. Minus the probability that x is equal to 1, which was found up there. Minus the probability that x is equal to 2, which was found up here. Minus the probability that x is equal to 3, which was found up there. You subtract all of them from 1, and that gives you 24.2%. And that is the final probability. Next one. You're not going to do all of this. I will encourage you to go through the rest yourself and find out clearly which one you are dealing with. For example, suppose that the number of customers arriving each hour at the only checkout counter in a local pharmacy is approximately distributed with an expected arrival rate of 20% per hour. Based on this, you can easily tell whether it's binomial or Poisson. Which one is it? Is it binomial or Poisson? Binomial or Poisson? Binomial or Poisson? Okay. This one is fairly simple. It's Poisson. It's Poisson. There's no doubt. Why? Because everything is happening within the hour. Everything is happening within the hour. Okay. Now that it's Poisson, it means that you got to know the mean, then you got to know the x. You got to know the mean and then the x. The mean and then the x. The x comes from within the question. Based on this, we were told that the mean, which is the expected arrival rate, is 20. So that one was clear. So it means that the mean is 20. But the x, we were told that The first one is exactly 10. So if it is exactly 10, how you find it is find the probability of x is equal to 10. Simple. And then you can use the mean and the rest to find it. The B part says at least 5. At least 5 means you are finding the probability that x is greater or equal to 5. Remember the sample size, the average customers is 20. So if you're finding at least 5, that is going to be quite long because you're doing at least 5 means 5 all the way up to 20. Okay. And that is quite something. That is very something. So what you want to do, you want to find 1 minus the answer. So you got to find 1 minus the probability that x is less or equal to 4, rather. So that you can do probability for 0, probability for 1, probability for 2, for 3, and then for 4. When you finish, you subtract all of them from 1. So when you look at it, I've just gone through all of that. Then that will give you a beautiful. I'm going to go to the last probability. Okay. I'm going to go. By the way, here is the 20 that I told you about, and then all the things that. Let me jump this and then go to the next one, the final probability for today, and this is known as normal distribution. Now, before a normal distribution, let me tell you something small. This is basic. This is basic, beautiful statistics. I get it. Now, normal distribution, you have a population, and out of the population, you take a sample. So let's say that this is a population of students, and you take a sample from that. You try and find out 2 things about every random variable, if you can remember I told you. You find the mean, you find the standard deviation. The population, the mean is known as the population mean. And then the sample, you calculate the sample mean. So the population is giving you a parameter, the sample is giving you a statistic. Okay, that's the first thing. And this is what you normally get. So the sample will give you this mean if you are dealing with the mean of the sample. But if you are dealing with the mean of the population, you get a mu. The standard deviation is S for the sample and sigma for the mean. Now, binomial distribution, we know there are 2 possible outcomes. Poisson distribution, we know that we are dealing with the mean of possible outcomes. All of them are not continuous. They are not decimals. Everything is integers. They are discrete. But in real life, in real market systems, so many things are continuous. For example, your salary is a continuous variable. You can have $2,500.50. That 0.50 cents is showing some decimals. So it shows that it's continuous. Your height is a continuous variable. Your weight is a continuous variable. You get 70.43 pounds or 43 kilos or something. Life is, there are so many natural phenomena, psychological, educational variables that are all approximately normally distributed. The word normal distribution comes from the Gaussian, it's also sometimes called the Gaussian distribution because it was discovered by the German mathematician known as Carl Friedrich Gauss. Let me tell you a little bit about the normal distribution because so many things are normally distributed. For example, look at the average height of people. Majority, average height of people is basically between 5 and 6, generally. Maybe some are below, some are above, but majority are within this area here. Weight. Well, you check the majority of people's weight is around, 40, maybe to 80. I mean, the numbers are so big, but then the majority are within this circuit. So weight is normally distributed. Height is normally distributed. Salaries are generally normally distributed. If somebody is earning way more, they are few, they are outliers, we say. Even your scores, your exam scores are normally distributed. Majority of you will be getting within the average, C and D there. or C, and and then few will fail, and few will also get top A. So things in life are generally normally distributed, and so we need to find those things, and these are typical examples of things that are normally distributed. Now, I want you to think about the normal distribution curve. Look at it here. This is a normal distribution curve. The normal distribution curve is the distribution of the random variable that I told you about some few minutes ago, where these random variables can be height, weight, salaries, and them things. Okay. Those very things are things that people, sometimes look at them and what do they do? Let me just clear all of this. Okay. People sometimes look at them and then they disrupt them. Now, the area under the normal curve is the most important thing. Look at the normal distribution curve. It has three parts: the base, the center, and then the area. The base, the center, and then the area. My question to you is that how many percent is the area? If you look on the screen, how many percentage is the area of the normal curve? How many percent? How many? How many percent? Type it there. How many percent? Type it there for me. 100%, exactly, 100%. Half of the area is 50%. The other half of the area is 50%. Ladies and gentlemen, I'm using the word area. This area here is the same as the probability. Write it down. The area under the normal curve represents the probability distribution, the probability in percentage. Our goal is to do something. Now, please pay attention. Please pay attention. The area under the normal curve is a very important thing because it's representing the probability. Now, if I tell you that, if I draw a line here and I tell you that this area here is 30%, then I tell you that, and I'm giving you some letters, and I tell you that this one is A, and this area is B, and this area is C, and I tell you that this area is 10%, the B is 10%. What do you think is the area A? What is the area A? If I tell you that this corner here is 30%, now I want you to tell me the area A, the area B is 10%. I'll also come and tell you to tell me the area C. What do you think is the area A? A is 20%. Why? It's good. Because the whole of the left of the area is 50%. And so if the 50%, you have 30%, then what is the left? Is 20, correct? So the A is 20%. I agree. What about the C? What is the percentage value for C? C is 40%. I agree with you as well. C is 40%. You see, the essence of this 40%, this is probability. And so the probability tells you the chance of something happening. Our job is to find these areas. That's our job. So if I wanted the area A, because I want to find the probability, the 20%, I would have shaded the A. I'll tell you, find me the A. If it is a C I'm looking for, I'll shade it. I'll tell you, find me that probability or that area. Let's get a sense. How do we get there? How do we get there from a random variable X until we get a probability P? Well, we need to get something that will help us to move a variable from a random situation to a possibility of its probability. There's something that can help us to do that. That is the essence of this last topic. By the way, remember that the mean is always the center of the normal curve. Okay, the mean. is a center. And if you have the mean to be the center, the mean is the center of the random variable. So if the random variable is x, then there are many x's on this here, from negative to positive. And please remember that anytime you are moving in this area, you move from the center to the left. You move from the center to the right. So anytime you are moving, you move from. So suppose you have an area, two areas here, and this is A and this is B. Looking at the movement, which area can you cover first? Is it the A or the B? Looking at the movement and how we move, which area will you cover first before you reach which area? Which area can you cover first? You cover A first, exactly. Because you move from the center, you cover the A, bypass the A before you get to B. So what if I don't want the A and I want you to find me the B? Then I must know the A before I can get the B. Because once I know the A, I'll subtract it from 50% and I'll get to the B. Job done. Now, let's look at an example. How do we get there? Okay, how do we get there? There is something that has already been done already. The distribution of the normal, of the random variable, which is normally distributed, the distribution is defined by its mean and then its standard deviation. And we know that the normal curve is unimodal. It has one mode. Okay, when you look at it here, okay, the mode is one. It's not like this one, which has two modes, okay, which will say that it is multimodal. Okay, it's not like this. Okay, the mode is the top, the peak one. It's unimodal, and we also know that it's symmetric. It's symmetric. It divides the whole thing into half, okay, perfectly into two. So we know that as well. Now, because of that, some people have done some great thing for us. And because it follows the normal probability density function, the area under the normal curve can always be found by finding the number of standard deviations the value of the random variable is from the mean. Okay, so when you know the mean, let me draw it for you again so that you don't get confused. Watch it. Okay. Watch it. You have this. I draw this one. I indicate the mean in the center. That's the mu. I don't know the value yet. I write the standard deviation here. I don't know the value yet. But everything is a random variable. Everything on the axis here is a random variable. Okay. If I want to find something there, okay, let's say I want to find the shaded area. If I want to find the shaded area, I have to calculate, I have to determine the number of standard deviations that this value, let's call it X, which I don't know, that this value, this random value is from this mean. How many standard deviations it is away from the mean. And there is a standard normal table that has been used already, calculated already, for you to know all of this. It's already been computed and they are available in tables, and it can be used to compute all the probabilities or all the areas. That's what we are going to do. But before you can use the table, you got to know the formula. And ladies and gentlemen, this is a normal formula. It is on your screen. Write it down, please. Write it down. This is a normal formula. The formula that will convert any normal random variable that has a mean, that has a standard deviation, to the standard normal for you, so that you can use it to find the probability. This is what you want to write down today. Write it down. So remember, I told you that every time you have a random variable, you got to know the mean and you got to know the standard deviation or the variance. And for each one of them, we've got it. And now the last one, the normal distribution, we also have it. Where is the mean? The mean is a U. Where is the standard deviation? The standard deviation is a sigma. And then the X is a random variable. We are going to use this Z formula to help us to move from somewhere to somewhere. Where? To move from the X, passing through the Z until we get to the probability. Beautiful. We need to move from the random variable X. Using the Z, it can help us to find the area, which is a probability. Using this formula, we can do that. So if I know the X, since automatically I will know the mu and then the sigma, which is the mean and the standard deviation, the two will be able to help me to find the Z. Now I can go and read the Z from the table and find the probability, which is P. I think an example will do, don't you think so? 2 examples will do. That will be done for today. Let's start with one example. It's fairly simple. Okay. Let's start with all of these things. You can look at them as well. So these are some of the areas that you're finding. For example, if you take the first one, example number 1, if I want to know the shaded area here, what do? I have to find the probability, the area, which is this one, which is 50%. Then I'll add it to this one. Okay. I don't know the value yet. Let's say it's A. I'll add it, and then I'll find my area. What about the second one? The second one, if you want to find this shaded area, because the movement is like this, you need to find this one first and subtract it from what? 0.5. Once you subtract it from 5, that will give you the outer layer here. What about this third one? This third one, in order to find the redded area, you find this area, which is straightforward. You find that area, which is straightforward, and then add the 2 of them. That will give you the red area. So you can see that some of them you add 0.5 to them, some of them you subtract 0.5 from it, and all of that. This one, you added a 0.5. This one, you subtracted one of the value from 0.5 before you got it. This one, you didn't do anything, you added the 2 values before you got it. We're going to do a lot of examples of this. Let's take a practical one, an easy one. In fact, let me take a very natural one, then we work with that natural one twice. Boogers. Boogers. They sell furniture. They sell carpet. From records, management have observed that the mean number of yards of carpet demanded every week is 4,200 yards. Remember, I told you that you'll be given the mean always and then the standard deviation always. The mean is 4,200. The standard deviation is 1,004. The manager want to know what the probability that the demand for carpet next week will exceed 6,000. You see, he wants to know probability. What is the chance? What is the chance? What shows that people are going to demand a lot of carpet next week? On average, every week, the mean is 4,200. The standard deviation is 1,004. So what is the probability? By the way, if the standard deviation is lower than the mean, as it is here, it's always sort of a good thing. It means that, firms, the observations have got a similar, sizes. The sizes are similar. But if the standard deviation is bigger than the mean, then it means that there are some that are way bigger. Some of the observations are bigger than others. In other words, some of them are too big and some of them are too small. And this will usually be reflected in the higher standard deviation more than the mean. This is just something I'm giving it to you for your research purpose. For now, what is the probability? So what are we looking for? We are looking for a percentage value. What is the probability that demand for carpet will be more than 6,000? Well, ladies and gentlemen, this is simple. In order to get this, you have to draw. So let's draw it together. You first have to draw something beautifully like this. And then you showcase the mean and the standard deviation. Do you remember? Okay, so I'm going to draw it. Showcase the mean. So you draw your normal curve like this. And then the mean is always the center, right? And that mean, you write mu. We were told that it is 4,200. So you write it there. Then the sigma. We were told that it is 1,004. So you write it there. And then we're told that we are looking for something 6,000 yards. My question to you, and the question you must always ask yourself is this. This 6,000, is it to the left of the mean or to the right of the mean? Let me know. Is it to the left L of the mean or is it to the right R of the mean? Just put it there. Just put it there. Just put it there. Some of these answers, they need quick answers. When it requires a lot of explanation, I'll ask you, is it to the left or right? L or R? I agree with you. It's to the right. So because it's to the right, you can identify anywhere here to the right. Anywhere here. And then you locate the number 6,000. Remember that 6,000 is the X, the random variable. So now we know that it's to the right, but watch the question. The question says that find out, the manager wants to know the probability that demand for carpet will be more than or exceed 5,000. So my question to you is that, which area are we going to shade? Is it the A? Is it the B? Is it the C? Based on that, will exceed 6,000. Which area are we interested in? A, B, C. I agree with you. We're going to shade the area C. That's what we are looking for. You must always draw this. So we are looking for the area. Remember, the probability, the area, the same thing. How do we get that shaded area? Remember, the movement always starts from the center and goes to the right. But from what we are seeing in the screen, it means that we have to bypass B before we get to the area C. So whatever probability we are going to find, we must get the probability for B first. And once we get the probability for B, what do? You can tell me. Now I need a voice. Once we get a probability for B, what do? In order to get that of the C. Once we get a probability for B, because remember, we start from the center and go up. What do we do once we get a probability for B? Esther.
When we get the probability for B, we'll minus the B from 0.5 to get the probability for C.
Perfect answer. No question about it. That's it. Now, how do we get the probability for B? We need to use the standard normal formula. What is that? This is a formula. Standard normal formula is a beautiful formula that says that Z is equal to X minus mu all over sigma. What is the value of X? Is there 6,000. So you write 6,000. What is the value for the mu? Is there? It's 4,200. So you write 4,200. Divided by what is the value for sigma? Is there? It's 1,004. So you write 1,004. You take a calculator, 6,000 minus 4,200 divided by 1,004, correct to 2 decimal places. I want somebody to give me the answer. I know it, but I want you to tell me. 2 decimal places. What do you get? 2 decimal places. What do you get? 1.29, correct. Good job, Philip. So you write 1.29. That is your Z value. This Z value is what is going to help you to find your probability. How do you get it? Take the Z table. So go take the Z table. Go look for the Z table. So you can take your own Z table. I'm taking my own Z table. Or you want me to give you my Z table? Okay. Let me give you my Z table. I could show you, but this is my Z table. Okay. This is my Z table. That's my Z, that's my Z, what's my Z? Okay. So Z table, this is it. The table is designed in a beautiful way for you to know what you're looking for. So the Z value we are looking for is 1.29. Watch on the far left, they are the Z values, far left. So you're going to look for the value 1.2 because you don't have the 9 in addition. They are always 1 decimals. but the 2 decimals are read at the top. So you read the other one at the top here. So you select 1.2. So if it is 0.73, you would have selected 0.7 under 3 here. Okay. If the value was 0.73, you'd have selected this 0.7, and then you'd have chosen under 3 here. And then the value would have been this 0.2673. But now we are looking for 1.2 under 9. This is the 1.2. Under 9, you keep going, and whilst you're looking for the 0.09 up there. So 1.2 under 9, what value do you get? Okay, so you pick the value here, 1.2, and then you drag it all the way to the right here, under 9. And under 9 is at the top here. This is under 9. This is the last one. Okay. And you see that the Z value is 0.4015. Hallelujah. Got it. Now that we got a value of Z, we can now go ahead and use that to get our answer that we're looking for. Therefore, how do you write it? Remember, the 0.4015 is not the answer we're looking for. That gives you the B, just as we agreed. That gives you the B. So what we got to do now is to write our probability answer. The probability of X being greater than 6,000, right, is going to be 0.5, because remember, we got a 0.41. Okay, what we got was the 0.4015. So 0.5 minus the 0.4015, because what we are looking for is not the B, but it's rather the C. So we've got to take what we found, the probability of what we found, out of 0.5. One of you said it. And that will give you what value? You can tell us. Excellent. Philip, you're really working along with me. It will give you 0.0985. So you get 0.0985. Which one you convert it to percentage is 9.85%. So what this means is that the chances of you getting demand for carpet exceeding 6,000 is very slim. Why? Because we were told that on average, we always get 4,200, every week. 4,002 every week on average. And you are telling me that it will exceed 6,000. It will exceed 6,000, meaning it can be 1 million. How can you move on an average of 4,200 to 1 million? Because that exceeds 6,000 was too wide. The chances are slim, 9.85%. That is how you do it. Now, let's look at another one. Okay, we're getting to just one more, and then we are done. Let's go and look at a situation of another, the same thing, carpet, this time on a different one, the second one, the one I've highlighted. What is the probability that demand for carpet will be between 3,000 and 5,000? Between 3,000 and 5,000. So that means that again, you have to what? You have to draw it. How do you draw it? Fairly simple. How do you simplify it? Okay. So what we got to do now is that we got to draw 3,000 and 5,000. Just go this way. Then draw your mean. Take the middle. It's still 4,200. It's still 1,004. Now we're looking at 3,000. Is it to the left or right of the mean? 3,000. Is it to the left or to the right? Excellent. It's to the left. So we just identify somewhere on the left here. Then we have our 3,000 written down. Then the next one is 5,000. Is it to the right or left of the mean? 5,000 to the right or left of the mean? Perfect. It's to the right. So now identify 5,000. The question says between them. So if I have a space Let me label some of the spaces. Suppose I have a space called A. I have a space which is A, B, C, D. Which space am I looking for? Which space am I shading? Which space am I looking for? Exactly, B and C. And so this is what you shade. You shade that. And that is the area you are looking for. How do you get that? Well, it's simple because the movement is from the center going leftward and from the center going rightward. So whatever I find, whatever probability values I get, I will add them. Boom. Because I get the space quickly. Fantastic. You're done. What is the 3,000? Well, if you check and you do the 3,000 very well, the 3,000 is going to give you something like this. Let's see if I can show you. The 3,000 will give you something like 5,000. Okay, so this is a 5,000. The 5,000 will give you a z value of 0.57. Again, you can see it. It's 5,000 minus 4,002. Divided by that, that'll give you 0.57. If you go to your table and go and read 0.57, we can check it. If you go to your table and read 0.57, you have to read 0.5 here, under 7. What do you get? 0.57. You read 0.5 under 7. What will you get? 0.5 under 7. You don't need to say you don't see. If you take your eye carefully, you will know. 0.5 under 7. Exactly. Exactly, Michael. Exactly, Priscilla. Exactly. Okay, so you get 0.217. Because that will hit on here. That's what you get. And that means that for the 3,000, you get that value. And that is what you got here, 0.217. Now, what about the 5,000? If you calculate the 5,000 has actually been calculated already here. Let me just go and show you. What is that? 5,000. Okay, you can easily calculate the 5,000, to be honest with you. But the 5,000 is somewhere, I think we could have easily done that. Okay, so this is it. This is a 5,000. Is it? No. Yeah, this is a 5,000. And then, so this is a 5,000. Then the 3,000. The 3,000, I think we've done it already. But it's the same principle. If you do the 3,000, okay, you get something like this. There you go. A 3,000 will give you 0.3. Now let's see how you could have done it. I mean, you can do it. I know you guys are smart. You can do it. If you do that, you get something like, this value, and then you go and read it, and you get 0.3051. I'm sure you can do it, right? Excellent. Many of you are saying that you are smart, you can do it. But if you think you cannot, it's just 5,000 minus the 4,200. The same thing. I mean, sorry, it's just 3,000 minus 4,200. You get a negative value. I think you get negative. Who has done it? Who can tell me the value you get? You get 3,000 minus this. What do you get? Exactly, negative 0.86. Negative 0.86. So when you come to the table here, most of you are good there. This is negative 0.8 under 6. You just have to look for under 6. Negative 0.8 under 6. What's the value? You see the answer there? This one, 0.3051. That is negative 8 under 6. And now that you got it, just add the 2. Because the 2, according to the graph, the 2 must be added. So you get 0.3051. You get 0.210. Add the 2. And boom, you get your final beautiful answer. There are several examples that you can do. Okay? And then you can get your beautiful work nicely, perfectly done. That's it. 0.52, 52%. Okay. So there are several criteria. I've worked a number of them. I would want you to check it and look at it. Also, you should learn this beautiful one. Please, any question? If you have a question, raise your hand. So we've been able to calculate how to move from how to move from the X. Once you know the X value, you can use the X value to find the Z value. Once you know your Z value, you can use your Z value to find your probability value. That's it, which is P. What if you are moving the other way around? What if now you already have been given the probability? You have to use it to find the Z. Once you find the Z, use the Z to find the X. You will learn that too. Because I have some videos on that you can check. Franklina, do you have a question? Yeah, let me know.
Yeah, Doc, even though we don't see negative on the normal distribution, we should just choose any value.
Because it's a mirror image of the positive, you should always see it as a positive value.
Okay.
Yeah, it's positive because whatever is on the left is what is on the right. The negative sign is simply showing that it's on the left of the mean. That's all. The positive sign is showing that it's on the right of the mean. But it doesn't matter because you don't need the negative because you're only using the number to find the probability. Your interest is in the probability, not the number itself. All right. Another question. Another question. Any question, Marcus? All right. So here's the thing. How do you move from the probability back to the X? Because we looked at all the situations where you move from the X to the probability. Here's the thing. You can find the X if you have been given the probability. It is very important. It's a little bit tricky, but it's doable. What do I mean? We have shown how to compute the probabilities given the Z values. Sometimes you are rather given a probability, you got to work your way backward to find out. For example, look at the Z formula. It is Z equals to X minus mu all over sigma. If I want you to find me X, how do you find me X? You cross multiply, and then you move this one to the left side, and then that gives you your X. If you cross multiply, you get Z sigma. Z sigma equals to X minus mu. You move the mu to the left-hand side, okay, and that gives you mu plus sigma, Z sigma equals to X. So it's easy to do change of subject to find out. Sometimes the question is in such a way that you are rather giving the probability for you to find the X. But in all of the ones you looked at, you are rather giving the X. Then passing through the Z, it can give you the probability or the area. Let me give you an example. It will help you. Let's take this example. Suppose the price of waakye is normally distributed. The mean is 8 cedis. The standard deviation is 5. Question. What should the price be? You see, he didn't ask you the price. He didn't ask you to find the probability. Rather, he's asking you, what should the price be? He didn't ask you to find the probability. He didn't ask you to find the area. He didn't ask you to find the percentage. Remember, the probability is the same as a proportion or a percentage. He's rather asking you, what should the price be so that 20% of all prices are below this price? Let's try to picture what it's trying to say. It's beautiful. Okay. Thank you for the reminder. Now, look at this. I'm drawing it. This is our normal distribution. This is a mean. In this question, we are told that the mean is what value? 8 cedis. So mu is equal to 8. But remember that mu is also one of the random variables because X is the random variable. And all of this area, the horizontal section here, all of them have X. So if mu is 8 cedis, it means that 9 cedis is above it, 10 cedis is above it, 7 cedis is below it, okay, below it until 0 is up here. We are told that the standard deviation is 5. So that one, I will just put it below that of the mean. Now here's the question. It says that I want you to tell me a certain price. Which price? It is also on the horizontal line. You see, 8 cedis is a price. And I want you to tell me a certain price. I just don't know where the price is. The price is on this line, horizontal base, the baseline here. I don't know the price. I wanted to find me the price. But the clue for you to get me the price is that 20% of the other prices are below this price. Watch this. 20% of all the prices are below this price. Now, if you have this line and you are going to percentage, the percentage will start from the 0. So as you go to the right, I'm moving to the right. As you go to the right, go to the right, go to the right, go to the right, with the arrow showing going to the right, okay? Or if you like, I will just show you here like this. Okay. So I can go to the right like this. As you go to the right, you know what's happening? The percentages are increasing, all right? So if I ask you, for example, what percentage is at the mean, what would you say? As the percentages are starting from the 0 here, going to the right, okay? They're starting from the 0, going to the right. So if I were to ask you, now what percentage is at the mean, what would you have said? At the mean, just at the mean here. What percentage is at the mean? Who can tell me what you would have said? What percentage is at the mean? I need to get smart guys. Excellent, beautiful guys. I love you. The percentage is going to be 50%. Okay, good. So it means that we know that the 50% is here. Okay. Now the question says that I want you to tell me a certain price. What should the price be so that only 20% of all prices are below this price? So I will need a certain price. The price, I don't know. The price can be here, can be here, can be here, can be here, can be here. Okay. But I want the price in such a way that only 20% of all prices are below this price. So the question mark that I'm looking for, is it going to be to the left of the mean or to the right of the mean? I'm deleting the question marks. Is it going to be to the left of the mean or to the right of the mean? If 20% of all prices are below this one I'm looking for, then the question mark I'm looking for, the question mark price, is it to the left of the mean or right? Excellent, you are good, super. It's going to be somewhere here. So I want this one, so I need to draw a line here like this. I want a certain price here. I don't know this one. And 20%, so it means that 20%, this shaded area, 20% of the price, because 20% is from 0 here to here. So this is the 20%. So that 20% of the prices are below this vertical line price. Now you have drawn it. You see, when you have drawn it, you get a better understanding of everything. You understand what I mean? Yeah. Now that you know that 20% of the prices are below, what value do you think is here? What percentage value is here now? What percentage value is here? You know it. What is that? 30%, exactly. Remember, even if we want this vertical line price, we always start from the center and go leftward. Do you remember? We always do that. We always start from the center like this. We always start from the center like this, going to the left. So we need the 30% more than we need the 20%. So we need this 30%. So now we know that the probability is 30%. Because that is why we need to cross before we can get what? We can get that vertical line price. Okay, fantastic. That is a probability. So I need to go to my table and dump that probability there. So I go to my table here. I'm going to look for that 30%. 30% is more important because that's where I need to pass before I get to my vertical line price. So I pass there, I go here. I'm going to dump it here. So I'm looking for the number closest to 30%. I'm going to search the table. Search. I'm going to search. Looking for the number in the swimming pool. Remember the probabilities, the percentages are all the things in the swimming pool, not the edge, not the vertical top edge, not the far left edge, no. I'm rather searching for in the swimming pool of the table. So let's look for two numbers that are usually closest to 0.3, 0.3, 0.3, 0.3. Now we get 0.2 and then 0.3. Okay, let's go. 0.3, 0.3, 0.3. Which two numbers are closest to 0.3? Which two numbers are closest to 0.3? 0.3. Have you found them? Well, one thing you can always do is that if it is 0.3, go to the lowest number for 0.3. So you see, at this stage, if I go here, it's not working because they are all 0.299. Now, at this stage, I'm between two numbers here. These are the junction of the whole thing. These two numbers. These two numbers are my firepower. One is 0.3023. We don't want the 23 because we want 0.3. One is 0.2995. Which of these two numbers do you think is closest to 0.3? Because one of them is the number we are looking for. Which of their numbers is the closest number to 0.3? Which one? Which one? Which one? Exactly, I agree with you. It's 0.2995. Now that we know it's 0.2995, we are done. We are done. We are done. We are done. At this stage, now that we know it's 0.2995, you read the Z value on the left, boom, and then on the top, boom. Therefore, our corresponding Z value to this number is 0.84. Our corresponding value is 0.84. But don't forget something. The area you are looking for now, was it to the left of the mean or to the right of the mean? It was to the left. And anytime a Z value is to the left of the mean, the value must be what? I think one lady just asked me the question some few minutes ago. The value must be what? Negative, because it's to the left of the mean. If the area we're looking for, or the Z value we are looking for is to the right of the mean, then you attach positive to it. So it is going to be negative 0.84. Now we have gotten the corresponding, remember we were given the probability. We've been able to use this probability to find the Z value, 0.8/4. Now we got to substitute it into our formula, that we have. What's the formula? Let me just go back here. The formula we have is this. Remember, it is Z equal to X minus mu over sigma. Now, we know our Z value. What's the Z value? It is, so we are going to substitute this. The Z value is negative 0.84. Remember why it's negative. Equal to X. X is what we don't know. Minus a mu. The mean is what was given to us. It was 8. Okay. Divided by the standard deviation. The standard deviation was given to us. What was it? 5. At this stage, you can find the X easily. Cross multiply the 5 by the negative 0.84. And then move the minus 8 to the left-hand side. And then find your answer. Okay. If you do that, this is what you're going to get. You're going to get a value for X that you've been waiting for all these years. Let's check that. Okay. Everything I did is here, by the way. Now I explain how you get the whole thing. Now at this stage, you will get the value, which is this negative, and then I explained all of that. When you do that, you're going to get to this value, which is 3.8. That's what you get. But you see, the 3.8, we shouldn't be surprised. You know why? Because it is truly on the left of the mean. Remember, the mean was 8, and we find a value of 3.8, which is exactly to the left of the mean. Because when you go and look at the graph clearly shows that we are looking for a certain price, and that price is to the left of the mean. You know what is beautiful about this? What this means is that 20% of the prices are below 3.8 cedis. That's what it means. 20% of all the prices are below this 3.8. The question I need you to think about now is this. What if the questioner said that I want you to tell me the price in such a way that 10% of the prices are above this price? 10% of the prices are above the price. I want you to tell me the price in such a way that 10% of the prices are above this price. If 10% of the prices are above this price, we'll go to the right here. 10% of the prices are above this price. So it means that we are looking for 10% here. 10% of the prices are above this price. Oh, sorry. What I've just given you is the top 10% of the prices are above this price. Okay. But if I were to go by the 10% of the prices are above this price, 10% of the prices are above this price. Yeah, it's the same thing here. The same thing. Okay. So I just need 10% of the prices that are above, because remember, as you move up here, you're going towards 100. Okay. Hold on, let me be sure. Yeah, it's the same thing, because you're going to just do the mirror image. Okay. If you say 10% of the prices are above this price, 10% of the prices are above this price, it's the same thing here. Okay, so you get 10%. And that means this one is 10%. It means that you're going to look for 40% and search for the 0.4 in the table. And then go and read this corresponding Z value. And that gives you the answer. Now, sometimes, let me go to we are ending. Yes, Miriam.
Sir, could you please clarify why the 10% is at that area and not where the 0.4 is supposed to be? Because I thought it says if 10% was above what's the median price, right? Which is the mean price, which is...
No, it didn't say the mean price. It's not the mean price. It says that I want you to tell me a certain price. I need the price. I don't know the price. But the price I'm looking for, 10% of all the prices are above this price. Okay. Now, another way of saying this is that, okay, let me try and get it. Another way of saying this is that 90% of all the prices are below this price. That's another way of saying it. I want to repeat that. Okay. 10% of all prices are above this price, this question mark price that I'm looking for. Okay. 10% of all prices are above this price. Another way of saying it is that 90% of all prices are below this price. Now, why did I say that? It's the same thing. Because 90% is from 0 all the way up to here. So from here up to here is 90%, which means you bypass the 50%. And then you've added 40% to the 50%. And that brings it here. So this one is what you're looking for. You're saying that I want the price in such a way that 90% of all the prices are below this price. And it's true, when you come to this question mark price, 90% of the prices are below it. You can see it. So suppose I get the value of this to be 11, and it's true that 90% of the prices are below 11 cedis. But the previous question says 10% of all the prices are above this price. Now, 10% of the prices being above this price, it cannot come down. It will go up here. So he's talking about this area here, that 10% of these prices are above a certain price. Which price? This question mark price. I don't know this question mark price. But what I know is that 10% of the prices, what I know is that top 10%, the top 10% of the prices are above this price. And because of that, then I'll just take the top 10. I'll just take the 10% of the prices because they are the only ones that will be above this. And then the rest of the 90% will be below this price. Chidi, you get it?
Yes, I do. Thank you.
The same way, if I say that I want a price where 70% of the prices are below this price, 70% of the prices below this price will be here. So you just have to take the 50 and then the rest is what, 20. So we are looking for 20. And then, so the 20 is what you are going to read to find, the 20 is the probability, the 20% is the probability. Forget about even the 50. You can read the 20%, find the Z value and substitute. And remember, it's going to be plus. Everything to the right will be plus. Everything to the left will be minus. Go and look at some of these examples that I worked in, and then you will be fine, ladies and gentlemen. This is the beauty. This is the end of the entire caboodle. What a day. And I have multiple questions for this with their solutions that you can check later, and then you can answer some of them better. Remember, until what you know becomes what you do, you don't know anything. The evidence that you know is result. You got to benefit yourself. You got to benefit those who listen to you. Then you can know that you have given them. If you are lacking knowledge to navigate around situations, then you seek mentorship, you seek guidance, you seek support. You don't rely because your capacity is limited. The files in your brain muscles are not there. And so once you get a mentor will guide you and will walk you through your desert. Okay? The mentor will walk you through your desert.
The funny thing is,
The mentor will walk you through your Red Sea, through your desert, and take you to your promised land. You need to find a guide. That's the only way to get to your Canaan. Then, gentlemen, that brings us to the end of the entire caboodle.